All right, this is the homework for lines of fit practice. Lines of fit practice. And let's get started. Number one says Marty and Betty opened a new store called the Trendy Cafe. Their goal is to reach profit of $25,000 in their 30th month of business. And the table and scatter plot below represent the profit in thousands of dollars P that they made during the first 12 months of their business. All right, so you have all this data, and it says A, draw a trend line. Can't really do that on this here, but it's going to be something with a line that goes through there, right? So it's a general trend line. You want to get a line that hits as many points as you can. It has to be a straight line. B, it says determine the equation of the trend line. So that we can do. We're going to use our calculator, and we're going to use stat to find the equation. Don't forget to make sure you have your correlation coefficient turned on, that diagnostic thing. If you don't know how to do that, go back and watch the video. So we're going to go over to edit, and we're going to type in all of that, like the whole table, right? So 1, 2, 3, 4, 5, 6, 9, 10, 11, and 12. And then we have 3.5, 3.0, 4.0, 5.5, 7, 6.5, 7.5, 7, 7.5 again, 8, 9, and 8.5. All right. It says it's going to be, let's see. It's going to be a linear equation. If you look, it's kind of going in that linear function. Plus, you want your profits to continue going up. You don't want it to curve back down, right? And it's not going to be an exponential function that goes like crazy high. It's just a linear pattern. All right. So stat over to calc, linear regression, and there it is. So the equation is going to be y equals 0.517. Let's do 3 decimal places. How about that? Does it say? No, it doesn't. Let's do that. So 0.517 and x plus 3.053. And then C says, what is the correlation coefficient and is it strong or weak? It says CR is equal to 0.94, and that is a strong positive correlation coefficient. Okay. Strong positive correlation coefficient. Remember, the closer it is to 1 or -1, the stronger it is. The closer it is to 0, the weaker it is. Okay. D, it says, if their profit continues along this trend line, predict whether Marty and Betty will reach their goal in the 30th month. So we're going to plug this equation into y equals 0.517x plus 3.053, and then table. We're going to go when it says their 30th month, so when x is 30. There's 30. Now it says 18.5. You remember this is in thousands of dollars. So D here, it says 18. When x is 30, y equals 18.563. Remember, it's in thousands, so it's really $18,563. And no, they did not meet their goal of $25,000. So no. All right. Number 2. The table shows the number of stores owned by a popular coffee house over an 8-year period. Use a graphing calculator to find the equation for the best fit line that best models the data X since the number of years since 2009. So for number 2, remember that 2009 is year 0. So we'll do 0, 1, 2, 3, 4, all the way to 2016, right? Okay. So edit, stat, edit, 0, 2010, 2011, 12, 13, 14, 15, and 16. Okay. Let's do that one more time. 2009, 10, 11, 12, 13, 14, 15, and 16. All right, that is 8 spots. Good. All right. Then we will type in 905, 8545, 9286, 10186, 11865, 11556, and 12725, and 13533. Right, stat. It says it's going to be what type? Line of best fit. All the options are are linear. If you look at A, B, C, and D, it says that it's x. It's not x squared. It's not to the power of x. So we know that it's going to be a linear regression. And there's our crazy number, right? So which one does that line up with? It's roughly 727x plus 8292. So we're looking for basically that, which is A. Okay. 3, 4, and 5. Determine whether to use a linear, quadratic, exponential equation and state the correlation coefficient of determination. So first we have to decide if it's linear, quadratic, or exponential, and then we have to type it in here and find the R value, right? So it's R for linear and it's R squared for exponential and quadratic. So here we go. Number 3. You remember we're just paying attention to the y's, but I'll go ahead and write the table down. 0, 2, 4, 6, 8, 10. Then 1.1, 3.3, 2.9, 5.6, 11.9, and 19.8. So you remember you subtract, right? The second from the first, third from the second, on and on and on. So 3.3 minus 1.1 is 2.2. 2.9 minus 3.3 is negative 0.4. 5.6 minus... Okay, I see where this is going. Okay, so this isn't accurate. This isn't like a perfect world data, so it's not going to work out all nice and pretty. So what we're going to do is we are going to plug this into stat and do linear regression, quadratic regression, exponential regression, write down all the different R values and see which one works best with it. Okay, so we're going to use our R value to determine if this is linear, quadratic, or exponential. So stat, edit, delete all this stuff. And then we're going to go with 0, 2, 4, 6, 8, and 10. And then we're going to go with 1.1, 3.3, 2.9, 5.6, 11.9, 19.8. And we're going to hit stat, over to calc, try linear regression first, because that's first on the list. And look at our R. Our R value for linear is R equals 0.9, let's call it 1, 4, right? Or 0.915. For quadratic, and we go down to quadratic regression, and our r is equal to 0.980. 0.980. Then we look at exponential and see that we should be looking at r squared, r squared value. And then let's see, over to exponential, which is 0. And that r squared value is 0.948. Okay, so this one has the highest r value, so it must be quadratic. Do you see how we did that? We used the correlation coefficient to determine which one it was. The one with the highest value is going to be the answer. So it is a quadratic set, and it is going to be r squared equals 0.980 for the r value, for the coefficient of determination. Okay. Correlation coefficient is for linear. Coefficient of determination is for quadratic and exponential. All right, number 4. Number 4, we're going to plop all that data into stat. So 0, 0.1, 0.2, 0.3, 0.4, and 0.5. Then 12.1, 9.6, 6.3, 5.5, 4.8, and 1.9. We're going to hit stat, go over to calc, hit number 4 for linear. So linear, my r value will equal negative 0.975. For quadratic, it is 0.964. R squared is equal to 0.964. And then stat, over to calc, 0. Exponential regression says r squared is 0.90. So exponential says r squared is equal to 0.90. So the one with the highest correlation, you remember, it doesn't matter if it's negative or positive. The one with the highest correlation coefficient is going to be linear. So it is a linear equation. Number 5. See if we can get this one done before I have to start a new video. All right, number 5, edit. Change all these values to 1, 1.5, 2, 2.5, 3, and 3.5. Change these values to 2.5, 4, 8, 15, 22, and 50. All right, stat over that. Stat over that. Linear regression. Linear for number 5 will be r equals 0.898. Quadratic will be r squared, which is 0.964. And then exponential, let's see, stat over to 0 for exponential. And wow, r squared is 0.9934. So this one's definitely exponential, and there is our r value. All right, I'm going to go ahead and stop the video here because I don't think I can finish number 6, 7, and 8 in a minute. So I'll make another video. All right, have a good day.